Hello everyone. Today I want to explain to you about my current experiment. So my experiment is about PPO, and then I'm using this script. This script is about minimal implementation of PPO, and this is using Python. Okay, and here this is the script that I customized because the script is just a minimal implementation. Okay, and first I will explain to you about the environment that I'm using for this experiment. Okay, so basically the environment I'm using is lunar lander. So if you don't know, lunar lander is like this. Here I'm using the pre-trained model that I trained, something like that. So we want this base or machine to land between this flag. So when it's land in here, the reward will be bigger. Now how this work? Okay, let's to the main loop. This is the main loop. And this is the most important part because this is the training loop. And as you can see here, we have two loops, outer loop and the inner loop. This outer loop is to dictate how many trial or running that we want to run. And for the inner loop, this is the episode in the single trial. So first, when we initiate a trial, we will doing the environment reset here, and we will get the initial state, and then this is the current reward that is 0, and then after that we enter to the inner loop, and then after that we select the action using the model. PPO agent variable here is a model here. The model of PPO, the definition is in here in the PPO script. I will explain this later. And then after that we get the action, and then the action will be fed to the environment, and from this we will get the new state, the reward for the action, the terminated state and truncated state, and the additional info. And for the terminated and truncated state, I merged them in the done state. And then after that, we save all the new state, reward, terminated, and truncated. Here we save reward and done. And you must be asked, when we save the state, when we save the new state? Actually, in the PPO here, when we doing the select action, we save the state, the new state, the action, and the log probability of the action. That's how we save the state. Okay, and then after that, here there's the line for the continuous space and then non-continuous space. The continuous space, what the meaning of this continuous space is, it's the environment when the action option is not discrete, but in this lunar lander, this is the discrete case. But for the continuous space is when the input for the environment is a real number. And as you can see here, we will update or train the model when we reach a certain time step here. So when it's not reached, it will keep collect the data set. Okay, let's move to the PPO, the update function in here. As you can see, I want to clarify something that in my previous video I say that advantage is reward, but it's actually not correct, because actually advantage is the difference between rewards and the estimate rewards from the model. and I already stated this in the comment of my previous video. And then here, this is the main loop for the PPO. Here we try to evaluate, actually we try to evaluate using the state. This is the old state and this is the old action, and after that we will get the log probability state value, and this is the entropy. Entropy is to state how uncertain our prediction. Okay, and this is we change the torch to the we change the state to the torch, and here this is the ratio. This is actually same with my previous video. Okay, I already explained this. Okay, until this. Until this, I already explained until this line. This is the loss that we use, and as you can see here, there are three components. The first component is clipped, the clipped PPO that I already explained, and the second MSA loss between the estimated rewards and the actual rewards. And then the third component is the entropy. And after that, we doing the backpropagation. And then after that, we load the wake and bias. In my experiment, I want to investigate that what if we, I forgot to mention that in this PPO, we're using a neural network, and in this neural network there is two components, that is actor and the critic. Here the actor and this is the critic. The actor is the use of this actor is to decide the action, and the critic is to estimate the reward. So the critic is like to decide that if our action is good or bad. So that's why in the last layer we only have one neuron, because we just want to output a single real number. Because of that I want to know that actually, as you can see here, the critic in the actor critic model, we can get rid that and the model will be run fine. But I want to know if that will be affect the performance of the model or not. And the second is, as you can see here, there's the entropy component. I want to know what if we get rid this entropy. And as you know, because it's only a single formula, if we just get rid this, the script will be run fine, but the performance may be different. So that's why that is the point of my experiment, and for that I already prepared the different script. This is for the script for the complete PPO, and this is the script for the if we using PPO but we don't use critic, and then this is the script for what if we using the actor critic and PPO but we don't include the entropy. And then the last is what if we only using the actor and then we get rid the entropy too. Okay, and if we run this script, actually the time run for the script is quite long. It's take about half hour. After we run this, we will get the pre-trained model in here, and then the log for the reward in here, and in the background I already run all of them, and the result it's like this. Here this is the time step, this is the reward for the actor critic. This is the average reward. Okay, this is the actor. This is the actor critic is the complete PPO. The actor here is just we just using actor, and no entropy here. We see actor critic but no entropy, and actor no entropy here. We just using actor and no entropy. I forgot to mention that the difference between these three script is just in here. Import the different PPO. And oh yeah, and for the PPO na entropy, as you can see here, we just get rid the entropy here, and the for PPO that just use actor is here. As you can see here, the advantage is just same as reward, not use the MSA loss. We just using the advantage that is the same as reward, and this is the result. And as you can see here, there is gap between the scheme that is with entropy and no entropy. And as you can see here, when I'm using no entropy, the effect reward is increasing, but we using the entropy, the effect reward is decreasing. We can conclude for the case of the lunar lander, using no entropy is better. And then after that, the difference between when we using critic and not using critic, and as you can see here, there's no much difference. I think this is the statistic parameter that I measure. We have a maximum, standard deviation, and then average. And as you can see here, the standard deviation for all of this scheme is quite high, bigger than 60, and that's why I recommend that when you train the lunar lander using PPO, I recommend that using the early stop. So when it reaches the threshold score, it will be stopped. This is the threshold score, and for this I recommend that, because as you can see here, it can reach the 200 easily if we using no entropy. Then for the threshold score, we can use number like 210 or 230 or something else. Okay, I think that's all. Thank you.